Hi, welcome to the dynamics tutorials. So in this problem we're going to look at the equations of motion, otherwise known as Newton's equation, to solve a problem that's in rectilinear coordinates. And this is going to be a kinetics problem, so we're going to look at the acceleration as a function of the forces. So with this problem we have a crate that sits on a flat surface. We have a coefficient of both static and kinetic, so just one single coefficient of friction of 0.1. And then we have a force that's applied that's equal to t cubed, and the units are such that the force is in newtons when the time is in seconds, and then this crate is 50 kilograms. So anytime we're doing a kinetics problem, our very first step is always going to be to draw the free body diagram. So here's our free body diagram. We have the weight of the object, we have the normal force, and then we have the frictional force going opposite the direction of any motion, and then we have our applied force that's equal to time cubed. So our first step is to figure out how much time elapses before this thing starts moving, because initially the force is 0, and so it's just going to sit there for a while until the force ramps up high enough to cause motion. So we'll do a sum of forces and the y is equal to 0. That gives us the weight coming down is negative and the normal force going up is positive. That allows us to solve for the normal force. The frictional force is the coefficient of friction times the normal force. Plug that in. That gives us the constant friction. And this is the maximum friction that we can have for this problem. So this will be the friction at impending motion, and then it will also be the friction once it starts moving. If you have a problem where they give you the two coefficients of friction, then you'd use the static here, and you'd use the kinetic over here. But we just have one, so we're just going with the single one that we have. So solve it as if it's a statics problem and do sum of forces in the x is equal to 0. That gives us the frictional force going in this direction plus t cubed going in this direction equals 0. And then we can solve for that and then just take a cube root to give us the time. That gives us a time of 3.661 seconds. So that would be the time at which you have impending motion, that the box begins to be on the verge of moving. So for 0 to 3.661 seconds, there is no motion. We don't need to consider that. And then for time is 3.661 to 5, that's when we have motion, so that's when we need an acceleration. So we do our sum of forces in the x based on the same free body diagram. So we have the same frictional force going in the negative x. We have the t to the third power going in the positive x. That's equal to the mass times acceleration in x. And then we can solve for that acceleration. And we'll notice that the acceleration is a function of time. So what we're going to have to do is go back and look at the basic differential equations. We can't use an integrated expression for this one. So let's see what we're supposed to be finding. We're supposed to be finding the velocity and the acceleration. So we found the acceleration. We just need to plug in that value for t is equal to 5. But to find the velocity, then we could use this equation because we have velocity, time, and acceleration. So dv dt is equal to a would combine those three quantities. Multiplying through by substituting in here and then multiplying through by dt would give us that dv is equal to negative 0.981 plus 0.02 t cubed times dt. And then we could integrate that. Our crate is initially at rest, so it's a velocity of 0, integrating that up to a velocity of v, and then we're integrating from our time that we just solved for, 3.661, up to a time of 5 seconds. This gives us then integration of dv is v, plug in v, plug in 0, so it's just v minus 0, and then integrating this gives us negative 0.981 t plus 0.005 t to the fourth power, and then we have to evaluate these two from 5 to 3.661. So you plug in t is equal to 5 in both, and then you'd subtract off and then plug in t is equal to 3.661 in both. Once you do the subtraction, you get that the velocity is the 0.913 meters per second, and it kind of ran out of space, so with the acceleration you could just plug in here yourself the t is equal to 5 and solve for the acceleration. Thanks for watching.